Alright, so our goal here today is to come up with the reasoning of why we divide fractions the way we do. I'm sure most of you recall multiplying by the reciprocal, or the weird little saying, don't ask why, just flip the second and multiply, or something like that. As with the theme of this class, we don't like just doing little shortcuts like that without an actual explanation. So we're going to look at a familiar example, something that we did when we first started talking about fractions, and go from there. So last night I made 10 face masks, and this was only 5/6 of the total that I planned on making. So what was the total I planned on making? Again, if you recall, this is a type of example that we looked at when we first started talking about fractions. So let's break down what this means right here. So 5/6 of the total, what does that indicate about the total? The total was broken up into 6 pieces, and the 10 face masks is only 5 out of those 6 pieces. So let's get a little number line going on here. This is 0 face masks. The end is the total number of face masks that I wanted to make. Again, by our understanding of fractions, we know this 5/6 means that the total number was broken up into 6 pieces, and the 10 face masks represents 5 of those 6 pieces. So let's break this up into 6 pieces. 1, 2, 3, 4, 5. There we go. And again, these 5 pieces represent the actual face masks that I made. So I want to figure out what was the total. Well, I have 5 equal size pieces here that total up to 10. So how do I figure out what one piece is? Yes, so I should take the 10 and divide that by 5. So I get that each of those pieces is has a size of 2, step size of 2. And how many pieces do I actually have? I have 6. So 2 times 6 gives me 12. I intended on making 12 face masks. So when we originally talked about this, I asked what operation is this foreshadowing, and most people picked up on this is division, division of fractions. I divided by 5 and multiplied by 6, which is the opposite of what that appears to do. So let's look at this problem in kind of a formula aspect. So I know that, let's let M be the total number of masks that I had anticipated making. So I know 5/6 of the total number of masks is 10. So 5/6 of, we already talked about the concept of, meaning multiplication. So 5/6 of the total number of masks is 10. So is usually conveys equality. So there we go. So of, we know, is multiplication. So I have 5/6 times M. I'm going to write it this way. M times 5/6 is equal to 10. Now, we've talked about before, addition and subtraction are inverse operations. If I want to undo the addition, I can subtract. If I want to undo the multiplication, I can divide. So my goal here is to divide, or to get M all by itself, right? I want to know what the total number of masks is. I'm multiplying by 5/6, so to get rid of that, I could just divide by 5/6. So I'm going to divide both sides by 5/6. On the left-hand side, it cancels out and gives me M, which is what I wanted, and I get 10 divided by 5/6. Now, this doesn't help me at all because we haven't defined what this actually means or figured out how I'm actually supposed to do that. So I'm going to backtrack. I'm going to go back. Saying 10 divided by 5/6, I don't really know what that means, so I'm going to come back up here. M times 5/6 equals 10. We looked at the other day when we were trying to compare fractions. If I had A over B equals C over D, I could multiply both sides by B, multiply both sides by D, and get a little comparison. We can essentially do the same thing here. a fraction is broken up into two parts. We know by multiplication, I can multiply straight across, so I'm actually multiplying by 5 and dividing by 6. So I can use the inverse operations to get rid of it. I'm actually dividing by 6, so I'm going to multiply both sides by 6. So I'm going to come over here. Boop. So I have m times 5, 6 equals 10. So I'm going to multiply both sides by 6, like I said. Use a little parenthesis action. I'm going to multiply this side by 6, and I'm going to multiply this side by 6. When I multiply the left side by 6, since I'm dividing by 6 and I'm multiplying by 6, those are going to cancel out. So I get m times 5 equals 10 times 6. And now to get m all by itself, I'm just going to divide both sides by 5. So I'm going to divide by 5, divide by 5. On the left, since I'm multiplying by 5 and divided by 5, those 5s are going to cancel out. So I get m equals 10 times 6 over 5. And so we can see here that 10 divided by 5, 6 actually means 10 times 6 over 5, which is where that whole flip the second and multiply or multiply by the reciprocal comes from. So now we have the algorithm or the shortcut and the reasoning behind it for dividing fractions. So the algorithm tells us to take the second fraction and take the reciprocal of it and then multiply using the regular algorithm for multiplying fractions. So if I have 2/3 divided by, I don't know, 7/8, then the algorithm tells me to take the second fraction, take the reciprocal, which means to flip it over, and multiply straight across using just the regular fraction algorithm. So this is equal to 2/3 times 8 over 7. And now this is just a multiplication problem, so I'll multiply straight across. 2 times 8 gives me 16, and 3 times 7 gives me 21. So there's using the algorithm. Just like we modeled multiplication of fractions on a number line, we can also model division of fractions on a number line. So I'm going to use the same problem, 2/3 divided by 7/8, and look at it on a number line. So I'm taking 2/3 and dividing it by 7/8. So I'm going to take my original piece, which is 2/3. And what am I doing? Working backwards, I know I'm going to actually end up breaking this into 7 pieces. So 2, 4, 5, 6, there's my 7 pieces. And if I had thirds and broke each third into 7 pieces, I would now have 21. So my unit goes from 2/3 to 21st. So I'm going to have 2 over 21 as my unit. And I know I'm going to have 8 of those. So here's 1, 2, 3, 4, 5, 6, 7, 8. It's going to put me here, so I need to know what that is. So this is 2 over 21, 4, 6, 8, 10, 12, 14 over 21 does reduce to 2/3, and then I'll have 16 over 21. So that is the 8th step of the unit, 2 over 21, which we get from the algorithm.